Hi guys, welcome to Easy Math.
In this video, we are going to discuss about the type 2 of simplex method to solve the LPP. First point is the minimization type. In type 1, it is of maximization type, right? If it is of minimization type, we have to convert it into a maximization type by multiplying -1 on both sides and then proceed as type 1 method. Okay. Here the second one is all constraints are of less than or equal to type. This is same as of type 1, right? If all constraints are of less than or equal to type means we have to introduce slack variables. And the third one is all variables are non-negative. This is also same as that of type 1, right? Let us discuss the first problem. Solve the following LPP by simplex method. Minimize z is equal to 8x1 minus 2x2 subject to minus 4x1 plus 2x2 less than or equal to 1, 5x1 minus 4x2 less than or equal to 3 and x1 x2 greater than or equal to 0. In this problem, the objective function is of minimization type. Since the objective function is of minimization type, first we shall convert it into a maximization type. How we can convert it into a maximization type? While converting the minimization type to maximization type, we have to multiply -1 on both sides. If we are multiplying -1 on the left hand side, the minimization becomes maximization and the z becomes -z. Okay. Right hand side, it becomes minus 8x1 plus 2x2. And the remaining constraints and non-negative variables must be as it is, subject to the constraints minus 4x1 plus 2x2 less than or equal to 1, 5x1 minus 4x2 less than or equal to 3 and x1 x2 greater than or equal to 0. This is of less than or equal to type. Therefore, we have to introduce the slack variable s1 for the first constraint and s2 for the second constraint. Okay. Then you have to write the standard form. The standard form of the LPP can be written as maximum z star. Here this maximum minus z can be written as the another notation, can be denoted as another notation z star. Okay. Minus 8x1 plus 2x2 plus the slack variable 0s1 plus 0s2 subject to first equation minus 4x1 plus 2x2 plus s1. The cost of the slack variable s1 is 1 for the first constraint and the slack variable cost is 0 is equal to 1, and for the second constraint 5x1 minus 4x2, here the cost for the slack variable s1 is 0 and cost for the slack variable s2 is plus 1, and x1, x2, s1, s2 greater than or equal to 0. Okay. Now we have to write the initial basic feasible solution. How we write the initial basic feasible solution? You have to substitute 0 for the non-basic variable, right? That is for the x1 and x2. Hence, we are getting the basic variables s1 is equal to 1 and s2 is equal to 3 by using the constraints. Now we have to proceed on with the initial iteration, that is CB, YB, XB, X1, X2, and here the two variables S1 and S2 are given. Therefore, we are writing that also. In the initial iteration, you have to write the initial basic feasible solution, right? Here S1 is equal to 1 and S2 is equal to 3. And what is the value of the variables X1, X2, S1 and S2 in the constraints? In the first constraint, the coefficient of X1 is -4 and X2 is 2. S1 is 1 and S2 is 0, right? And for the second constraint, coefficient of x1 is 5, coefficient of x2 is -4 and the coefficient of s1 is 0 and coefficient of s2 is 1. And the cost for the variables s1 and s2 are 0 and 0. This is from the objective function, right? And now we have to find the value of Zj star minus Cj. Because in this problem, in the standard form, we are mentioning it as maximum Z star. Therefore, we are finding for Zj star minus Cj. Okay. First 0 into 1 is 0, plus 0 into 3 is 0. Again 0 into minus 4 is 0, plus 0 into 5 is 0, minus 8, that is plus 8. Therefore, the Zj star minus Cj value is 8 for the variable x1. And for the variable x2, 0 into 2, 0, plus 0 into minus 4, 0, minus 2. Therefore, the value is minus 2. And for the variable s1, 0 into 1, 0, plus 0 into 0, 0, minus 0, that is 0. For the variable s2, 0 into 0, 0, plus 0 into 1, 0, minus 0, you are getting 0. Okay. Now, Zj star minus Cj value. Here at least one value is less than 0, right? Here at least one value is less than 0. Therefore, this solution is not an optimal solution. Hence, we move on to the next iteration, right? Here, you have to choose the most negative. What is the most negative value here? Minus 2. Therefore, the entering variable is x2, right? You have to encircle it, right? And for finding the ratio, if there is any negative value in the pivot column, means you need not find the ratio for that particular row. Okay. Therefore, you have to find the ratio for the first row itself. That is how we find xb value divided by the corresponding column element. What's the value? 1 by 2. That is 1 by 2, right? Now, this is the leaving variable. The leaving variable is S1. Therefore, you have to encircle this. Hence, 2 is the pivot element. And the pivot element is 2. Okay. Now, finding the value for the first iteration by using these three values, right? Here, you have to mention this as first row R1 and this is R2. Now, we have to find the first iteration. First, you have to solve the first row. Okay. Here, the leaving variable is S1, right? Therefore, you have to solve the first row. Here, this is R1 dash, this is R2 dash. Now, new R1 dash is equal to R1 by the pivot element. What is the pivot element? 2. Therefore, the value is 1 by 2 minus 4 by 2, 2 by 2, 1 by 2 and 0 by 2. What's the value? 1 by 2 is 1 by 2, minus 4 by 2 is minus 2, 2 by 2 is 1, 1 by 2 is 1 by 2, 0 by 2 is 0. Okay. Next, we have to find the value for the R2 dash. How you find the R2 dash? You have to consider the second row, that is R2 minus corresponding column coefficient. What is the column coefficient here? Minus 4 into R1 dash. What is this? R2 minus into minus plus, that is plus 4 R1 dash. Okay. What is R2? 3, 5, minus 4, 0, 1. What is R1 dash? 4 into 1 by 2? 2. 4 into minus 2? Minus 8. 4 into 1? 4. 4 into 1 by 2, 2. 4 into 0, 0. You have to add these values, right? 3 plus 2, 5. 5 minus 8, minus 3. Minus 4 plus 0, 0. 0 plus 2, 2. 1 plus 0, 1. Therefore, the new R2 dash values are 5, minus 3, 0, 2, 1. Now, what's the cost of this variables x2 and s2? Here, the cost of x2 is 2. The cost of the variable s2 is 0. Now, we have to find the Zj star minus Cj. 2 into 1 by 2, 1. Plus 0 into 5, 0. Therefore, the value is 1. 2 into minus 2, minus 4. Plus 0 into minus 3, 0. Here minus 4, minus 8. That is minus 4 plus 8, right? The value is 4. Next, 2 into 1, 2. Plus 0 into 0, 0. 2 minus 2, 0. Again, 2 into 1 by 2, 1. Plus 0 into 2, 0. Minus 0, that is 1. Next, last one, 2 into 0, 0. 0 into 1, 0. Minus 0, the value is 0. Right? Here, all Zj star minus Cj values are greater than or equal to 0. All Zj star minus Cj values are positive. So, in this iteration itself, we obtain the optimal solution, right? The optimal solution is given by x2 is equal to 1 by 2 and here x1 value is not obtained, therefore the value is 0 and maximum z star is equal to 1. Maximum z star is equal to 1, right? But in the question, it's given as minimum z we have to find, right? Therefore, the minimum z can be written as minus 1. x1 is equal to 0 and x2 is equal to 1 by 2. This is the final answer, right? Just you have to multiply minus 1 to the maximum value you obtained, because while converting the minimization problem to maximization problem, you have to multiply minus 1 to the objective function, right? Here also you have to multiply minus 1 to the final answer for the minimum z only, not for the variables x1 and x2. Okay. For converting minimization to maximization, we are multiplying minus 1, right? Again, we are converting back to minimization means we are again multiplying minus 1. This is the concept.
Thank you for watching. Don't forget to like, share and subscribe. Bye guys.